Okay, here's the trapezoidal rule. How do we find the area under the curve? We usually find the area under the curve by taking the integral, finding the integral over the definite integral over a particular interval. However, many functions cannot be efficiently integrated, so we have other what we call numerical methods, and one of those methods is the trapezoidal rule. So to find the area under the curve using the trapezoidal rule, what we do is we kind of break the curve up. We draw a number of offsets, these vertical lines, offsets. And then we just complete trapezoids, connecting those offsets. And there I have 4 trapezoids. We would say the number of trapezoids is 4, n equals 4. The height of each trapezoid, well, if it starts at A and starts at B, the height of each trapezoid would be the difference between A and B, B subtract A, divided by 4. So that would give me that height for each of those trapezoids. Remember, the height is the difference, the distance between the parallel bases. Okay? Now you can see it won't be 100% accurate, it's a little bit outside, but what I can do is I can increase the number of trapezoids. And that would make it a much more efficient process. So let me look at increasing the number of trapezoids. How many? Well, as many as I like. So I'm going to increase the number of trapezoids. Suppose I put in my first one here, my first offset, my second offset, third offset, fourth offset, etc. You can see how this is going, and complete the offsets like that. And suppose I kept going all the way along until I drew my last trapezoid over here. So that each trapezoid is an equal width. We're just going to call that h for the moment. And these are the base lengths, the parallel sides, the bases. We call those the offsets. And if I think about these, we're talking about, instead of saying 4 now, we're just saying there is n trapezoids in here. And if there is, and this starts, the interval starts at an x-coordinate of A and finishes at an x-coordinate of B, the height of each trapezoid, that horizontal distance there, would be equal to the difference between A and B divided by the number of trapezoids, B minus A over n. And I want to find the area of each of those trapezoids. Well, we have our trapezoidal rule, which says the area of any trapezoid is the average base length times the height. I have to be a little bit careful here. I don't mean this A and this B. We're talking about the average base length of the trapezoid. So if I want to find the area of all these trapezoids, well, the area of the first trapezoid will be the average base length times the height. To find the average of two things, we add them up and divide by 2, and then we're going to multiply them by the height. But, what are the base lengths? The lengths of these offsets. Well, this one will be whatever the y coordinate is here. Let's call that y1 and that y2 and that y3 and that y4. Now notice y2 is the endpoint for the first trapezoid, y3 the endpoint for the second, y2 the endpoint, y4 the endpoint for the third. So this would be y sub n and y sub n plus 1. Y sub n plus 1 would be the length of the right hand side of the last trapezoid here, if I have n trapezoids. So the first trapezoid is going to be y1 plus y2 times h. And then the second trapezoid, well, that's going to be y2 plus y3 over 2 times h. And then the third trapezoid, well, that'll be y3 plus y4, the average of those base lengths times h. And we'll keep going all the way up along until we have our last one, y sub n plus y sub n plus 1 over 2 times h. And what I can do here is I can factor out a h over 2. because there's h over 2 in every single term. And what I'd get is y1 plus y2. And then I'd get y2 plus y3. And then I'd get y3 plus y4. And then that would keep going on up until my last one, y sub n plus y sub n plus 1. And actually, all of these things are appearing twice. y4 will appear twice. Y sub n will appear twice. The only ones that don't appear twice are the length of the first offset, and the length of the last offset. And so actually, I could say that's h over 2 times the length of the first offset, 1, plus the length of the last offset, y sub n plus 1, plus, well, each of these is doubled twice, y sub 2 plus y sub 3, all the way up to y sub n. Okay, and if I want to kind of think that in relation to my function here, remember my function is called g, so y equals g of x. And the height we said was b minus a over n. Well, if I divide that by 2, I get b minus a over 2n. The height of the first offset would be g of a. I'm going to skip this one for the moment. I'll come back to that. The height of the second offset would be g of a plus h. And the length of the third offset would be g of a plus 2h. And the length of the fourth offset would be, g of, I've written that incorrectly. Let me put in that correctly. G of a plus 2h. And the height of the fourth offset, would be g of a plus 3h. Etc., etc. Okay, so y2, g of a plus h, y3, g of a plus 2h, y4, g of a plus 3h, y sub n would be g of a plus a number 1 less than n times h. Y sub n plus 1 will be g of a plus nh. Okay, so that's essentially how we use the trapezoidal rule. Okay? And we look in the next video at an example of putting that into play to estimate the area under a curve.